global warming.
Oh. We are gathered here today in mourning of our most beloved Earth, for it has perished due to the human race destroying it. I would like to thank all of you for coming out today.
I don't understand. How did the Earth die if it was only 2,106 years old?
Well, we needed to obtain energy somehow, and we did that by burning fossil fuels to power homes, cars, or businesses.
Wait, what? What are fossil fuels?
Fossil fuels are things like natural gas, coal, or oil that can be burned to power homes. The problem with these materials is that they release greenhouse gases into the atmosphere, such as the most abundant being carbon dioxide. Now, carbon dioxide is very harmful to the biosphere, but is most harmful to the marine ecosystem because of ocean acidification.
Oh, ocean acidification. I know something about that.
Ocean acidification is when carbon dioxide is absorbed by seawater and chemical reactions occur that reduce seawater pH, carbonate ion concentration, and saturation states of biologically important calcium carbonate minerals.
The carbonate ions are very useful to many types of shellfish, including the Penaeus monodon. The Penaeus monodon is a species of shrimp that lives about 20 to 50 meters deep in the offshore waters of the Indo-West Pacific Ocean. While they are native to this area, the shrimp are an invasive species and can be found everywhere in the world except the North and South Poles. They tend to live 2 to 3 years in the wild and are born by being hatched in eggs. The first hatched eggs are called neupli and look like tiny spiders that eat and survive on their yolk. Once grown to the mysis larval stage, the Penaeus monodon starts to eat algae and small invertebrates such as plankton, isopods, diatoms, and mollusks. This is where the Penaeus monodon starts to take the form of a fully grown Penaeus monodon. The fully grown Penaeus monodon has a carapace, or the hard upper shell, an abdomen, the paraeopod, which is the walking leg, pleopods, which are also known as swimming legs, antennae, and a uropod, which is a tail fin that is helpful with swimming. The Penaeus monodon also has a heart, stomach, and hepatopancreas, which is used as a digestive gland, and an esophagus, which carries food to the stomach.
Alright, but how does this affect the the shrimp thing you were talking about?
So the carbon dioxide is absorbed by the seawater and it binds with the carbonate ions.
Okay, but still, how does this affect the shrimp?
Shut up, we're getting there.
So the carbon dioxide binds with the water and carbonate ions in the water to create two bicarbonate ions. This hurts the monodon, as the monodon uses the carbonate ions to strengthen its shell and survive in the ocean. When the carbonate ions start being turned into bicarbonate ions, there is less for the monodon to strengthen its shells with, so the shells are weaker and give less protection against predators. As you can see in the graph and diagram on this slide, the graph shows that as the pH decreases, the percentage of eggs that are fertilized are decreased as well, showing that the population of Penaeus monodons is decreasing as the ocean becomes more acidic.
If the shrimp die off, it will disrupt the whole food chain, as the shrimp are near the bottom. The Pacific cod would not be able to eat as many shrimp, as some would die due to starvation, which would then disrupt the dolphin that eats the fish, and so on and so forth. Less availability of food of one organism means less availability of food for the rest of the food chain. The monodons would not only die due to weaker shells alone, but because they would lose their opacity, the ocean continues to become more acidic. It would increase the calcium levels in the shrimp, and the shrimp will lose their transparency, so it will be easier for predators to spot and eat. Not only would this affect the marine organisms, it would affect us humans. The Penaeus monodon is grown and fished in many places of the world for food and a source of income. If the monodon went extinct, the world would lose money, and the shrimp industry brings in billions of dollars with shrimp alone. Here's a map showing the regions where the giant shrimp are heavily hunted. Many small islands shown here rely on shrimp as their primary source of income. This lack of shrimp would influence the island's economy, therefore disrupting the country as a whole. As the ocean acidification increases, it would decrease the jumbo shrimp. This would affect the entire biosphere, as it would affect the primary producers of the jumbo shrimp in the food chain.
Wow, you know a lot about that. I wish there was a way we could go back and change that before the Earth died.
Well, there are alternate sources of energy that are other than burning fossil fuels.
Oh yeah, like nuclear energy and hydrogen energy.
Yeah, but I was thinking more like the batteries used in electric cars that reduce the need for gas.
That seems simple enough. Do you want to explain it?
The electric cars use electricity stored battery packs to power an electric motor and turn the wheels. In order for the batteries to work, they need a negative electrode, a positive electrode, and an electrolyte in each battery cell. The most common types of battery used in hybrid cars are nickel metal hydride batteries or lithium-ion batteries. The nickel metal hydride batteries are better for the atmosphere than the burning of fossil fuels to fuel a car, as the batteries do not emit greenhouse gases when in use. The nickel metal hydride batteries use potassium hydroxide solutions as the electrolyte, oxyhydroxide as a positive electrode, and use hydrogen stored as metal hydrate. The nickel oxyhydroxide reacts to form nickel hydroxide during discharge and vice versa when charging to power the battery, and use the energy stored in the battery. The other type of battery is a lithium-ion battery, and is going to become more common in electric cars in years to come, as was recently introduced to cars in 2015. The electrolyte in the lithium-ion battery can be many materials, but is usually carbonate solvent. The positive electrodes can be many things, such as LiFePO4, while the negative electrodes can be materials such as graphite. In both batteries, the energy is stored in the battery cells and is used during discharge when the current flows from the positive electrode to the negative electrode through an electrolytic field. These batteries have many benefits and are safer for the environment than the burning of fossil fuels.
The electric cars also have benefits when compared to gasoline cars. Electric cars produce less greenhouse gases than fossil fuels. They reduce the carbon dioxide emissions in cars by 22% when compared to cars running on gasoline. In doing so, they reduce smog pollutants produced by cars, which is a major problem in major industrial cities such as Beijing. The end of a gasoline car life emits about 57 metric tons of greenhouse gas emissions, while the end of an electric car life emits 28 metric tons of emissions, which is half of the emissions that the gasoline car emits. These cars are also cheaper to operate, pollute the air less, and electricity is cheaper to generate than gasoline. While it has its benefits, it also has its drawbacks. The batteries take a long time to charge, and if you forget to charge it overnight, your car will not run in the morning. The power plants also use fossil fuels to generate the electricity, which emit greenhouse gases, so it kind of contradicts the purpose of an energy-efficient battery. Many of the reactions used in the nickel metal hydride batteries are toxic, and potassium hydroxide is a poisonous substance that causes severe pain or vomiting, while nickel hydroxide is known to cause cancer in humans and animals. They also release harmful nickel carbonyl gas when decomposing. In the lithium-ion batteries, the reactions cause hydrofluoric acid to be produced, which is a major pollutant and a contact poison. These batteries also have a very high flammability and easily catch on fire if the environment it is in reaches high temperatures. In conclusion, the batteries are not worth it when being used to reduce the carbon dioxide emissions. Although they do reduce the emissions and have the potential to slow global warming at significant rates, the batteries are too dangerous to the environment and put Earth at an immediate danger. While global warming will have an increasing destructive effect on the Earth over the span of the next few centuries if Earth continues to burn fossil fuels to power homes and cars and businesses, if the Earth starts to implement more of the nickel metal hydride and the lithium-ion batteries, the Earth's environment will start to deteriorate at an increasing rate as well due to the harmful chemicals used in the battery's reaction and the materials the battery is made of. The toxic gases and cancerous materials in the batteries will not only harm the environment when left to decompose, but are also dangerous to the people who handle them. Also, the batteries only last a maximum of 5 years, and with about 25 million hybrid cars on the road today, every 3 to 5 years a battery will be left to decompose on Earth. The decomposition is harmful enough, but on top of that are the harmful reactions and electrolytes which are being used in the reactions every day. It would put the biosphere in extreme danger. It would affect the marine ecosystem and the animals in it, such as the Penaeus monodon, as well as the land ecosystem, both humans and animals. Animals would start to die off and it would disrupt the food chain, leading other animals to die off due to starvation. The populations of many important species would diminish, leading humans to struggle to survive as well. Overall, the batteries used in hybrid cars have more drawbacks than benefits and are almost as dangerous as global warming.